Good morning, pre-calculus students. Bringing your lesson to you today, we're going to continue to graph our polar graphs, and today I'm going to introduce you to another type. Yesterday we covered circles and rose curves, and we saw kind of some of the unique characteristics that create those graphs. Today we're going to look at a family of polar graphs called Limacons, and so you should have a note sheet that was provided for you so you can follow along and kind of add some notes to that as we go. I think you're going to find these graphs to be a little bit more easy and a little bit more straightforward. There's just kind of one key concept that we need to be on top of, and we'll kind of focus on that pretty early on. So let's jump right into it here today. So Limacons are all a family of functions that follow this same basic pattern. So if you take a look at both of our general equations here, you're going to see that we have r equals a plus or minus b times either cosine or sine of theta. All right. So all Limacon functions are going to fit into this format. All right. Now, each part of the equation is going to tell us something important. So let's kind of work a little bit backwards here. Let's start out with sine and cosine. All right. So sine and cosine really don't determine the shape. The shapes are going to look the same. What sine and cosine ultimately determine is the axis of symmetry. And if we think about what we know about sine and cosine, we know that cosine is always connected to the variable x, right? So if we have cosine in our function, our Limacon is going to have the x-axis as our axis of symmetry. If our Limacon has sine in its equation, then it will have an axis of symmetry of the y-axis. And we'll see that as we graph today. All right. Now, what does a positive or minus tell us in between the equation? Ultimately, it relates back to the axis of symmetry, but it really comes down to, are we on the positive or negative axis of symmetry? All right. So, for example, if I'm up in my equation here and I have a plus b cosine of theta, I know that it's going to have an axis of symmetry of the positive x-axis. All right. If that sign was negative, it's going to be the negative x-axis. Right. Now, the nice thing is when we get into graphing it, you don't even really have to think about these things. You're going to see how just by plotting the right points, that's going to naturally happen. So we really don't even have to worry about that. All right. But that is what those parts of the equations tell us. Now, a plus b is going to be something that we use as we graph. It's good for us to keep in mind. But a plus b is going to tell us the maximum r value. All right. Or essentially, what is the furthest that this Limacon is going to get from the pole. Okay. So those are kind of the key parts to the equation. Once we jump into actually graphing some of these, I think you're going to see how all of it works out very nice and easy as we again plot the right points. And we'll talk through which points you want to plot today here in our video. All right, so let's continue on. Now, A and B also tell us something else that is extremely important about the Limacon. And this is going to be the most important part of your work to identify today. All right, is there are actually 4 different types of Limacons, and which type of Limacon we have is 100% dependent on the ratio of A over B. All right. Now, all of these are the types of Limacons that we can create. And you can see that they're all kind of similar a little bit. They kind of have almost a circular shape to an extent. But what's different, and you could tell that this would be a Limacon that has cosine as its function because it's symmetrical on the x-axis. All 4 of them are. The other thing that we know is that it would have a plus sign in between the A and the B because it's on the positive x-axis. All right, so just to kind of connect back to the previous slide. But what A over B tells us is kind of what happens, on this one side of the graph, kind of close to the pole. All right, So we can kind of have four things that go on. We can have a Limacon with an inner loop. So you can kind of see this inner loop here around the pole. And that's only going to happen when we have an A over B ratio that is less than 1. All right. If A over B equal to 1, then we have what we call a cardioid, right? It almost looks like a heart. You can kind of see how we hit the pole and then bounce off, just like if you were drawing a heart, all right? And then if A over B's ratio is between 1 and 2, we have what we call a dimpled limacon. So you can kind of see how we have this, this kind of dimple right here, right? So, you know, some of you might have dimples when you smile, right? Just kind of these small little indentations. And that happens when A over B is between 1 and 2. If A over B gets greater than 2 or is equal to 2, we have what we call a convex limacon. It almost gets flat right through here, okay? And so you'll see how these are kind of determined even by the graph itself. But that's going to be one of the key things that we take into consideration first. All right, as we're graphing these limacons, we're going to determine what type do we have, and then we're going to go ahead and graph it. All right, so let me walk you through an example of each of these four limacons, how we're going to graph them, and how we'll identify a few key characteristics from them. All right, so let's jump right into it here today. All right, let's take this first limacon. All right, we want to graph r equals 2 plus 3 cosine of theta, okay? Now, a couple things I'm just going to quickly identify, right? When I see the 2 and the 3, right? So here's my A value, here's my B value. So first off, I know the sum of these, and ignore the sign here, right? We're just looking at it as an absolute value. So 2 plus 3 gives me a max R value of 5, okay? So I know that right off the bat, okay? Now, the next thing that I want to take into consideration is I want to think of the ratio of these two values, right? So A over B is going to give us 2 over 3, right? And then you can look back on that previous slide, and I know, hey, this number is less than 1. So that tells me that I'm going to have a limacon with an inner loop. All right, so I'm just going to put loop here, okay? All right. So all of that, I hope you kind of look at that and go, well, that's pretty easy to identify, right? So my max R value, A plus B. Determine its shape. Just look at the ratio of A over B. Obviously, you're going to kind of have to memorize those four ratios, but that's pretty simple. So then let's talk about how in the heck we graph this. And it's actually pretty simple, all right? We're going to plot some key points. And for all limacons, any equation in this format, we're going to use the same 5 points, okay? We are always going to work with angles of 0, pi over 2. That's an ugly pi over 2. Pi, not negative pi, ignore that. 3 pi over 2. And 2 pi, okay? Now, if you think about it, those are just kind of the key angles around a unit circle, right? We're basically working at 0, 90 degrees, 180, 270, and 360, okay? And I'm just going to go ahead and straight up plug them into my equation, right? And use what I know about the unit circle. Well, these points are all really easy to plug in, right? Because I know if I plug in 0 for theta, well, cosine at 0, right? If I think about my unit circle, that's 1, all right? So if cosine is 1, that means I just simply have 2 plus 3. So my R value is 5, all right? Now, I'm okay with that number because I know the maximum my R value can be is 5. So there's the max R value, all right? So I'm going to go ahead and plot that point. Well, let's hold on. We'll plot all of our points at one time. All right, so now let's plug in pi over 2. Well, pi over 2 is really easy for cosine as well because cosine at pi over 2 is 0. Right, so that means I end up with 2 plus 0, all right, so I get 2. All right, then I plug in pi. Well, cosine on my unit circle at pi is a negative 1, so I end up with 2 plus a negative 3, which gives me an R value of negative 1. All right, cosine at 3 pi over 2, well, I'm back to 0, right? So that means I have 2 plus 0 again, so I'm back to 2. All right, then if I go at 2 pi, All right. Now, a little logical thinking should tell us, hey, I should end up at the same point I was at 0, right? Because 0 and 2 pi are the same angle, and I need to kind of create this circular shape. But let's just verify that. So if I plug in 2 pi for my angle, right? Well, cosine of 2 pi is 1. 2 plus 3 is 5. All right. And so let's go ahead and plot each of these points. So at 0 degrees, I go out 5, 2, 3, 4, 5 units. All right. And then at pi over 2, I go 2 units. All right. At pi, I'm going back 1 unit. All right. And this is going to be what creates that inner loop. All right. Because I've got to go backwards. So we'll see how we utilize the pole to help create that inner loop. And so at 3 pi over 2, I'm at 2. And then at 2 pi, I'm back to 5, right? So I kind of complete my circle. So now let's just plot these points in the order in which we plotted them, right? So point 1, 2, 3, 4. Now as I draw this in a smooth curve, right, it's kind of circular in shape. So 1, 2, well, the only way I can get back to this third point is if I create this inner loop, all right? Reconnect here, and then I work my way through. All right. So again, I'm kind of creating this circular shape. So I've created this Limacon with an inner loop by just simply plotting those 5 points. Okay. Now, the one question we didn't answer is that how many zeros were there, right? Well, remember a 0 is where we cross the pole. And I'm just going to determine that once I draw the graph, right? So let's kind of retrace our path. So we started back here at 5, 0. So then we drew our way around and we passed through the pole 1 and 2 times. So we have 2 zeros to this graph. Now, I'm not going to ask you to find those. I just want you to identify that there are 2 zeros, all right? So here is your first example of a Limacon, right? We have a Limacon with an inner loop, okay? Now, here's what's not going to change from one graph to the next. I'm going to use these same angles in my significant points, right? I'm still going to use A over B the same way. I'm still going to count my number of zeros the same way. What's going to change is this ratio, right? So let's look at a couple more examples. All right, so let's take this one, okay? So right off the bat, I know my max R value, right? Taking A and B and adding those together. So 4 plus 4, ignore the sign in between, right? 4 plus 4 is going to give me 8. So I have a max R value of 8. Then I'm going to look at the ratio of A over B. So A over B is 4 over 4, which equals 1. So that is going to tell me that in this problem, I am going to have a Limacon that is a cardioid. All right, so remember, cardioid is that heart shape. Okay? And so our number of zeros here, we'll worry about that when we draw the graph. So let's plot some points. Again, we're going to use 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so if I plug in 0 for sine, well, sine's value at 0 is 0. So I end up with 4 minus 0, which is just simply 4. All right, at pi over 2, I know that sine is 1. So I end up with 4 minus 4, which is going to give me 0. At pi, I know that sine is 0. So 4 minus 0 is going to give us 4. 3 pi over 2, I know that sine is a negative 1. So I'm going to end up with 4 plus 4 when I plug a negative 1 in for sine. Right? 4 plus 4 is 8. Hey, there's our max R value showing up in our points. All right. Then at 2 pi, right? Well, at sine at 2 pi we know is 0. So we're back to 4. All right, so let's go ahead and plot these points. Now I'm going to let each circle is going to represent 2 here so I can fit 8 on my graph. All right, so just kind of keep that in mind. Each circle is representing 2 units. So at 0, I'm at 1, 2, 4, so I'm plotting that point. At pi over 2, I'm at 0, so I'm on the pole. Pi, I'm at 4. 3 pi over 2, I'm at 8. 2, 4, 6, 8. And at 2 pi, I'm back to 4, right? So here's our points. They almost look like a triangle shape, All right, but again, we're kind of drawing in this circular shape. That's the idea of a limacon. It's kind of circular. And so if I start at my first point, right, well, here I'm going to create that smooth curve. So I'm bouncing off of the pole to my other point. All right, hold on here. There we go. Get my pen going. All right. And there we have created that heart shape. Okay. Now, again, let's talk about our number of zeros. How many zeros did we have? Well, if we start our first point, we hit the pole one time the whole way through. So we have 1, 0. Now, let's connect it back to what we talked about on the very first slide. Just notice that this, because it's a sine function, we have an axis of symmetry of the y-axis. And because we have a negative sign in between, it is the negative y-axis. Now, we didn't even have to take that into consideration when we graphed it. It all just worked out through the plotting of the points. All right. Now, let's just real quickly here kind of talk about the difference between an inner loop and a cardioid. It kind of comes down to what kind of numbers show up, right? So a cardioid, we're going to see a 0 show up as one of the points. Okay. If I go back to my loop, right, we didn't have 0 show up in an R value, but we did have a negative number show up in an R value, okay? And so we want to kind of keep that in mind and see how that kind of impacts things as we move forward, all right? So again, notice with the loop, we had a negative R value. With the cardioid, we had a 0 R value. All right, let's graph our other two, and again, we'll continue on. All right, so just like before, first thing that I'm going to notice, hey, A plus B, so 4 plus 3, my max R value is going to be 7. I'm going to take a look at that ratio, so A over B is 4 over 3, which is greater than 1, but it is less than 2. So this tells me that I'm going to have a limacon that is dimpled. So let's plot our points. We've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right. So hopefully by now you kind of have the hint. I'm going to kind of move quick here. So if I plug in 0 for cosine, that's 1. 4 minus 3 is 1. If I plug in pi over 2, cosine's value is 0. So 4 minus 0 is 4. If I plug in pi, cosine's value is a negative 1. So I get 4 plus 3, which is 7. There's my max R value. 3 pi over 2. We know the cosine is 0. So I end up with 4 minus 0, which is 4. 2 pi, I know that cosine's value is 0. So I end up with 4 minus, cosine's value is 1. So I end up with 4 minus 3, which gives me 1. All right. Then I'm going to go ahead and plot my points. So at 0 radians, I'm going to let each circle represent 2 again. So at 0 radians, I'm at 1. At pi over 2, I'm at 4. At pi, I'm at 7. So 2, 4, 6, 7. And at 3 pi over 2, we're at 4. And then we're back to 1, all right? Now, there's nothing special that shows up in our R values, right? We don't see a negative number. We don't see 0, all right? And it's just our job to know, hey, this is going to have a little dimple to it. So when I draw this, right, it's going to kind of get a little out, around. This is an ugly limacon, but just kind of bear with me there. And there's my dimpled limacon, all right? Now, again, let's think about the number of zeros. How many times did we pass through the pole as we sketch this picture? Well, we didn't pass through the pole a single time. So our zeros is 0. Right? We do not have any zeros in this graph. Okay? All right. So there is your dimpled limacon. We've got one more example to graph. And so let's do that here and finish it out today. All right? So let's talk about what in the heck does it look like if we graph a convex limacon? Well, again, we're not going to see anything any different here. So start out with my max R value. 5 plus 2 is 7. I'm going to look at my ratio. So I'm going to take 5 over 2. Well, that is greater than or equal to 2. So I know that I have a convex limacon. All right, again, we're going to plot our same points. 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, do the same thing we've done all along. Plug them in. Think about our unit circle values. So at 0, we know sine is 0. So this is 5. At pi over 2, sine is 1. So we end up with 5 plus 2, which is 7. There's our max R value showing up. At pi, we know that sine is 0. So 5 plus 0 is 5. At 3 pi over 2, we know that sine's value is a negative 1. So I end up with 5 minus 2, which gives us 3. And at 2 pi, we know that sine is back to 0. So we're back to the point of 5. So again, just like every other one of our Limacons, we're just going to plot those points. Again, I'm going to let each circle represent 2 units. So at 0, we're at 5, 2, 4, 5. At pi over 2, we're at 7, 2, 4, 6, 7. At pi, we're at 5, 2, 4, 5. At 3 pi over 2, we're at 3, 2, and 3. And then we're back to 2 pi and 5. So we're back to our original point, right? Now again, if we look at this compared to the points in a dimpled Limacon, they look really, really similar. There's no negative R values. There's no 0 R value, right? Everything is just a positive number. But it's just our job to know that, hey, this is convex, right? So as I kind of create this smooth curve, I'm just going to kind of get down here. I'm not going to draw a dimple in it. I'm just going to, oh, I missed my point, but let's pretend that I hit it. All right, and that would be my convex Limacon. All right, there is graphing Limacons. I hope you agree with me when I say they're a lot easier than rose curves. Not as many things that we need to take into consideration, and really as we plot those 5 key significant points, it really works itself out really well. I should finish this problem off. Number of zeros. How many times do we pass through the pole? Well, not a single time, so we don't have any zeros. All right. Well, folks, that is your polar graph video for today. Your homework assignment is a worksheet, and then just keep in mind that we do have a quiz on Monday. All right, you guys have a great day. I'll see you Monday. We'll have time to answer questions before the quiz as well, but enjoy your weekend.